Hi, this instructional video is about solving quadratic equation. This time we're going to be solving it by square root function. Here's an example. Number 1, we have x squared over 25 minus the 1 equals 11. The question is, what could possibly be x? So if you took a square root and divided by 25 and take out 1, you'll end up with 11. Well, here's how you go about doing this one. To solve, you go add 1 to both sides of the equation. So you end up with x squared over 25 is equal to 12 because negative 1 and 1 cancels over here. Now, how do you get rid of the 25 denominator? Well, this says x squared divided by 25. So do the inverse of divided by multiplying 25 to both sides of the equation. So that the 25 and 25, they reduce to a 1x squared, or simply x squared. And 12 times 25, my calculator says 12 times 25 equals 300. So that's going to be 300. Now you start to solve for x. And to get rid of the exponent 2, you have to go inverse of square. Inverse of square is a square root. So you have to square root both sides of the equation. So square root of an x squared is simply x. Now anytime you take a square root of any number, there's a possibility of one being plus and one being a minus, positive or negative. Now 300, that's kind of like saying square root of 3 times 100. I know what a square root of 100 is. It's 10. So yay, we get out. 3, I have to stay inside. So you end up with 10 square root of 3. So if they ask you what are the solutions, you could say x is equal to 10 square root of 3 or negative 10 square root of 3. So those are your solutions. Now here's a variation. Okay? Now on this one, we're going to do the same thing. But first, let's get rid of the 1/3 coefficient outside of parentheses here. Let me rewrite that so I don't clutter things up. I'm going to multiply the reciprocal of 1/3, which is 3 over 1, or simply 3, to both sides of the equation. So the 3 reduces to 3, leaving me with 1 times the x plus 5 squared. So we got x plus 5 squared. On the right, we have 21. Now I'm going to get rid of the exponent 2 square by doing the inverse. The inverse of a square, like I said before, is square root. Whatever you do to the left side of the equation, you got to do it to the right side of the equation. So as the square root simplifies at the square, you are left with the binomial x plus 5 on the left side. And anytime you square root any number, there's a possibility of being plus or minus. Now 21 is made up of prime numbers 3 and 7, and therefore it cannot be simplified. Now we're going to go ahead and solve for x by subtracting 5 to both sides of the equation. Therefore the answer is x is equal to plus or minus. You know what? Let me write that in a more effective way. Negative 5 plus or minus square root of 21. There we go. That's better. Okay, in this case, the constant comes first. So if they ask you what's the solution, you say x is equal to negative 5 plus square root of 21. Or negative 5 minus square root of 21. And those are the two solutions. Okay, now let's have you try these two. Okay, now number 3 and 4, they look quite cluttered, but they do resemble something like number 2, and the idea is the same. So number 3, let's do that first, okay? Let's go ahead and isolate this first term over here, this whole expression, by getting rid of the negative 45. To do that, we're going to add 45 to both sides of the equation. So what you have remaining on the left side of the equation is now 2 times the quantity of x minus 6 squared, because negative 45 is gone. And on the right side, 53 plus 45, I see that's going to be 98. Now, we start to get rid of the coefficient 2, so we're going to divide the 2 to both sides of the equation, or you could have multiplied the reciprocal 1/2. So 2 and 2 simplifies on the left side of the equation, leaving you with x minus 6 quantity squared. And half of 98, 98 divided by 2, will be 49. Now you're going to solve for x by getting rid of the square. Inverse of a square is of course, square root. So I'm going to square root both sides. So square root of a square being binomial, we got x minus 6. Anytime you square root a number, you have a possibility of being plus or minus, positive or negative. And look, this is nice. Square root of 49, 7. Now you're going to solve for x by adding 6 to both sides of the equation. So x is equal to 6 plus or minus 7. Now, let's go ahead and figure this one out. So if they ask you, what is it? What is the solutions that would make this statement true equation? You'll say x is equal to 6 plus 7, which is 13. Or x is equal to 6 minus 7, which is equal to negative 1. So x equals 13 or negative 1. There's a solution. Now, if you didn't have a chance to try this one, go ahead and pause the video and try it. And I will go ahead and start verifying the answer, okay? Alright, here we go again. This number 4 is very similar to number 3, but without the minus 45 on this case. It's already set for you. So I have to think about getting rid of the 5. So you could divide the 5 to both sides of the equation, or multiply the reciprocal, which is 1/5. In this case, 5 simplifies out, become 1 times the quantity of x minus 7 squared. And 5 goes into 135, let's see, 2 and 7. Now to solve for x, you're going to do the inverse of a square, which is a square root. Square root of a square, the binomial just comes out by itself. Yay! Anytime you square root any number, you have a possibility of being a positive or negative. Square root of 27. And square root of 27, well, it's a composite number made up of 3 times 9. And 9 is a perfect square. So we're going to simplify this in a minute as we move the negative 7 by adding 7 to both sides of the equation. So we got x is equal to 7 plus or minus. And we said 9 is a perfect square, so 3 comes out. Whee! We're free. And who stays in? It's the extra 3. So when they ask you what's the final answer, what's the x that would make this equation true? Well, one of the answers for x has to be 7 plus 3 square root of 3. And the other possible solution is 7 minus 3 square root of 3. And those are your 2 solutions for that. There you have it. Exciting stuff.